Today, I will be talking to you about how we used Kafka at Wealthsimple during a period where we're growing pretty fast, as was the general business, which has a ton of implications on Kafka and the data in it, but actually mostly on the people. So there will be tons of content on like how to use Kafka, but do expect like stories and anecdotes. To start off, although I did get a really good introduction, thanks Brendan, I'm a person that likes distributed systems and going fast, and that doesn't like repeating myself, and also incidents repeating themselves. Like in general, if it's not new, like I'm not a developer for no reason. I like things to happen like once, and then I move beyond that. So at Wealthsimple, as mentioned, we're a financial services company. We're based in Canada, which is not mentioned on the slide because we usually do presentations in Canada where people obviously know that. Essentially, we aim to make financial services affordable to everyone in Canada, which has as implication that we're making a trading and investment platform that people can use from a mobile phone. As well as, generally speaking, keeping features lightweight and easy to use. One of the implications of that, like wanting to be affordable, is that we have to achieve scale and reliability without throwing money at the problem, which is something that comes very commonly with that type of problem. And that has some consequences. Like we want to achieve fast display, want to make sure that the application is responsive. And we also don't want to have like a team of people 24/7 watching that the packets are flying. Also, it would be really boring and probably not great for your careers. So that is a general scope. One thing to note about like financial services is that we hold information about money. And because we hold information about money, we have what's called the general ledger, which for all intents and purposes is a database. So whenever I mention it, because I will mention it, keep in mind it's like a giant database in the sky that has numbers in it. The numbers are really important. People get mad when they get the wrong numbers because sometimes they imagine that their money has vanished into the ether, which is usually not something that you want happening to you. Maybe to some people you don't like. So a long time ago, which is actually 2020, we were a lot smaller. And because we're a lot smaller, meaning also in number of clients, we have several million today, it was pretty easy. At first, we started using Kafka. And to be fair, before Kafka, we also used SQS and Kinesis to get updates from our main ledger. And the reason for that was when money changed somewhere, we wanted the other regions in the app to be aware that this had happened. Generating team was very small, like 50 people. So at the time, it was mostly a matter of making sure the front-end teams building the app were staying aware of the updates that you would get for the database based on like how much money had someone made as dividends this quarter and that sort of thing. And eventually, we ended up having a lot more users. That's mostly like 2021-ish time period. So if you remember, I know that it feels like forever today, but back in those days, the market was pretty strong. And so people that were listening to their friends telling them to buy stocks actually started, buying more stocks. Also, sometimes they read it on Reddit, I guess. So Reddit and people's friends brought us a whole lot more traffic, which means there was almost naturally, I would say, less reliability of the existing systems, which were not at the time Reddit sized. Meanwhile, because the product managers were not watching the whole Reddit situation, we still had new features. We're, like I mentioned, very small. That means that there's a huge market to be gained. And so people were like, well, we should have a better UX. Maybe we should let people, send each other P2P payments. People are doing things in the payment space. I hear that's hot. So all that is great, but it does mean that you have more services that need to listen to each other. And all those people realized that we had a Kafka deployment, which had existed at the time because of the ledger situation. So they had started using it to gain access to the data they needed. Wealthsimple uses domain-driven design. It always did. So it used it also before that point, which meant that, for instance, you had one team that handled like the client abstraction and another that handled the money abstraction. So each domain had its domain primitives. And when you needed something to change, you needed the data model for that domain to be updated. Because the entire data chain needed to be kept up to date, that is something that caused people to rely on the Kafka events even more, because then they could get data from another domain and didn't have to worry too much about asking them to change the model or care overly about new fields that had been added. So at the time, we began to see an explosion of people using Kafka. That was both new topics, new data in those topics, new versions of the data in the same topics. And we had like a growth of our teams at the same time. So about like 10 times in the engineering team, meaning that where we had like 50 engineers before, today we're 450. And so all these people also talk to each other less, except through Kafka, I mean. And that's also like a stage to set for all of these challenges, which is each new feature basically has this Kafka topic that is listening to for some reason that is clear to someone on the team. And the people that are producing into the Kafka topic usually don't know about the new feature. I think you can tell where this is going. So first off, models were pretty hard. I mentioned that it was cool for people to start up and be able to start using data right away. That's true, but then it also changed on them. So we fixed that by adding a schema registry, which helped in the sense that at least people could correctly parse the data that they were receiving, and the decoupling actually worked. However, it had other issues in that people kept having their schema evolve for reasons that they didn't always perceive. And it wasn't clear to people if their change was going to change the schema or not. At the time, we also didn't have anything like local development. That goes for the schema registry because we used the Confluent service, but that's also the case for the entire Kafka deployment. So at the time, it was mostly tested in production. That's also obviously an inch pattern. So chaos ensued. This is an excerpt redacted to ensure everyone's, I guess, safety of a set of Slack messages during an incident. There are like a few hours between all of these. I love the timestamps because I think they're cool. Essentially, it goes from like 2 p.m. to 9:45. And we had no real Kafka monitoring at this time. And most people hadn't been operating many things in production either. We still have no SRE team to this day. So developers do most of the operational work. So obviously there were incidents. There were a few of them at various times. And everyone started doing this complex migration plans where whenever they were touching the Kafka infrastructure in any way, people had to do this in sync at 8 p.m., which is conveniently after the markets close. So I guess we're lucky that markets don't close at midnight, because otherwise we might have had a few more difficult years. So we needed help. By this time, my team, which is a developer tools team, we had 2 persons in the team that were able to debug the Kafka stuff. So all 2 of them were very, highly requested. They were, one would say, strongly coupled resources. We started writing things. Writing things is a very underrated means of dealing with problems. So we wrote migration guides, and the migration guides did outline, you can run this at a time that is not 8 p.m., it will work. And that helped people have better work-life balance. We had maps of the current Kafka consumers and producers. If you've been to the keynote, you've seen the data stream monitoring product. Well, at the time, it didn't exist. So the mapping, who was consuming what, was a little more of an issue. And we had playbooks for different topics that people would commonly need to do. The main one was going to be deploying more consumers. If you've used Kafka compared to other queuing systems, the main complex things about Kafka is that you can get it to scale, but you need more partitions and more consumers for that to happen. The mechanisms to actually get more partitions and then all the consumers to consume the new partitions is somewhat arcane to people that have not read the docs before or worked with it. And so that was the part that we needed to document in a way that were a bit clearer. Also, we had good pictures. So at first, like I mentioned, we had nothing in the way of Kafka monitoring. Eventually, we implemented dashboards. It started ad hoc, like we have the service that is highly dependent on Kafka because it happens to get trading updates from it. So, let's add Kafka stuff to its main dashboard. And that worked, but then another service had a very similar incident for no reason, except that they had not found a way to port the Kafka stuff over from one dashboard to another. So we created template dashboards that people could just copy and paste on Datadog as well, because it's what we use for the dashboard generally, and templated monitors too. So that's a bit easier because they're defined as code in our infrastructure. People would just be able to copy the JSON that represented the monitors and then import a whole Kafka alerting config to their service, even if they, at that point, did not actually know what could go wrong. So that was the beginning of aligning and standardizing the Kafka infrastructure that we had. So we used consumer offset flag, messages produced and received, as well as the error rate, how much errors in processing we got. That's actually a log-based monitor for us. So we do have to notice how consumers report errors. That is something that is more of a pain point for us that I think it has been for a lot of people because we use 4 backend languages. So all those backend languages have different Kafka libraries that report errors in a different way. So we also had to align the different logs for all those libraries so that people were able to report the errors correctly. And one thing that we did that I think was probably the biggest change in that space is investing in the developer community. And I mean, not the SRE folks that we don't have, or the tools team, so my team, but all the other developers, a few of them were beginning to hear about this Kafka stuff. They were pretty proud about knowing about it. Those of them that did know about it. And the others were like, well, I hear distributed systems are cool. How do I get on that? So we set up a Kafka working group, which is kind of a community that meets sometimes to share best practices and has a Slack channel to share links. Full disclosure, shared a bunch of those links in the days that I've been here. And it also addressed design questions. So what does it mean if I have more consumers? And how does it scale? We set up workshops. Same thing. People that knew more about Kafka were able to teach others that were at the basic level of knowledge how to at least operate their service and then possibly how it worked. And generally, embrace contribution from other experts in the organization. And the reason we did all that is that the way it is now, we don't actually need to be present, for instance, when there's an incident to do root cause analysis on Kafka. We have plenty of experts across the organization that will show up and they will be like, oh, I've done something similar before. Let me help. And that has really scaled the influence that we had to a much larger number of people. To the effect that today, we actually don't have to directly intervene in incidents. We used to get paged, and sometimes by page, I mean the one person that knows Kafka got paged, not necessarily the team, for any Kafka incident that people had, but that those days are pretty much behind us now, which I'm beyond happy about. We also kind of gamified the process of actually learning from those incidents. So most people don't read postmortems. I know postmortems are awesome. We all like writing them. But the truth is, most people are not going to read it. So we made this cute little game, essentially a text adventure game on being an incident responder for Kafka, where you can choose a different path and you get a score at the end. And we got people to actually share their score and which path they took, which apparently motivated developers to actually try their hand at decision making. I was pretty happy because my team all got the best ending. So at least it validates something, right? We haven't slowed down. So one thing that is actually pretty important throughout all this, and which is why I didn't mention too much tooling, but we also introduced some tools, some configuration as code, so people are not manually creating Kafka topics, which would be untractable. But we have a config repo where all of this is defined as YAML. We had a few more Kafka-related tools that we introduce. For instance, we have this Kafka page in our Backstage developer portal that people can also go to learn about the producers and consumers that their service has. But throughout all this, people have kept creating all these topics at pretty much the same rate that they were before. Like, although they were learning, they have not like paused their normal activity. And that has caused a bit of a, I guess, architectural problem that hopefully we can now use Datadog and other monitoring tools to solve, which is we have all these producers and all these consumers that serve, I would say, interlocking purposes. And we do have an architecture challenge in front of us as far as unrolling all of this and deciding what actually needs to depend on what. So today we have like something like 100,000 messages a minute. This is like an actual number. This is an actual number as of when I was writing the slide, which is 1 month back. So it's probably higher now. But the point is, it is not marketing. It is true. All the members of our own team and most other engineers are able to get started with Kafka, write a new consumer. One good metric for that is that beforehand, when they were estimating their tasks, they used to have all these Jira tickets within the actual tasks that would include like writing the Kafka producers and consumers. And it would be something like 1 week each, which is a lot. Like, we're not writing Kafka consumers in Rust. There is not a ton of reason for a new Kafka consumer in JavaScript to take 1 week. And that has actually narrowed down a lot since these days. Today, it would take something like 1 day. And that's pretty much estimates that everyone is giving. We have also begun using it for, I guess, a variety of applications. I mentioned it a bit that we had like the Ledger case, as well as some of our trading applications. We use it for fraud detection, which is pretty common. We use it for also generic updates of settings and configs and all that kind of things. So it has really broadened, I want to say, its impact in the code base, which is also a consequence of more people being familiar with the technology. And that's it. I've been pretty short. To be fair, I am usually pretty short about these things. That's also because I want to hear from people, and it is very late. So hopefully keeps everyone entirely awake. And I have a couple useful links and references. So for choosing your number of partitions, I have a reference to the blog that we wrote on our Kafka deployment. And I wanted to upload the slide deck to my website before the talk, but now I will get the time to do it after. Definitely I have on the slide. Cool.
Awesome. Round of applause, please. And we do have a good bit of time for questions. I think just maybe 5 minutes. So who's got questions? You can either head to that mic or I can bring a microphone to you. Looks like we got a few over here. All right. I think I saw this gentleman's hand first. I'll come back to you in a moment.
Question. How are you managing your infrastructure? Are you like home rolling that whole thing, or are you using like manage like Kafka cluster and stuff like that, like AWS or GCP?
So there's about 2 levels to this. We use the managed Kafka clusters on Confluent. Although we did try other service provider than Confluent. We tried MSK, for instance, which is the AWS offering. They were all still hosted providers. We didn't try rolling our own. We do have a local development environment now. So people are able to deploy Kafka themselves in EC2 instances or in Docker Compose, but that's only for development. Production is still managed. And we use Terraform to manage our infrastructure, generally speaking.
Cool. Thank you.
Go ahead over there and I'll get you next.
I have 2 questions. I guess I'll ask them separately. The first is, so you described this pretty vibrant community around the Kafka. I feel like in my work, we've sort of struggled to build that community, or even around like languages. Like, could you talk a bit about, like, do you have like a virtual meeting cadence? Who is responsible for organizing the workshops? Curious anything about how you managed to make that successful and keep people engaged.
Sure, that's a great question. I'm actually really happy to talk about that. I think it's the key to like a lot of the illustrated initiatives, and people don't talk about the culture enough. So members of my team run the working group meetings as well as the workshops. The meetings are bi-weekly. Early on, we struggled to find people to add agenda items because they were a bit shy about adding stuff to the meetings. So we had to kind of manually push them to present and like tell them that we were interested in them. But overall, that has become more normal. And as far as the workshops, they are recorded, but people keep watching them. And one thing that happened when we're setting up the workshop is that one of the other developers essentially went over to us and was like, oh, I've been learning about Kafka. I think I'm something of an expert. Can I participate? And I was like, sure, help run it. So a lot of that is there are people in your organization that really care, and you have to take those people and essentially use them for pretty much anything that they want to do. That is the biggest advice that I can give there.
I'll let somebody else ask a question and just...
All right. And I was wrong on the time. We have plenty of time for questions. We've got like 15 minutes. So think of them and ask them.
Hi. From what I read here from your conversation is that you are monitoring the logs. On top of logs, what other props are you using? Are you using the Java implementation of Kafka for sending metrics? Or are you using the Kafka integration that give you the lag and all that stuff? And how you are managing that? Because we are having a problem where we have, I work for Goldman Sachs, so we have a lot of messages. And if you are using it, if you put a wildcard for the subjects, it becomes super heavy and super expensive. But at the same time, if you don't put a wildcard, then the subjects are very limited and it doesn't fulfill the task at hand. So I want to just hear how you are dealing with that.
Sure. I'll give a much more detailed answer. So there are a few levels. We have metrics on the Kafka brokers themselves. We use the Confluent and Datadog integration for that. We have since it existed. Before it existed, we were a bit stuck because Confluent didn't give us access directly to the metrics. So in that case, we couldn't do it on the broker side. On the consumer side, we do use like the Java metrics for Java consumers. We don't only have Java consumers. We have a lot of Ruby consumers where the metrics are natively a lot less detailed. And that is something that we have, to an extent, that is something that some teams have struggled with enough that, for instance, in the fraud team's case, they were originally using Python consumers, but they have begun using a lot less Python consumers and a lot more Java consumers for pretty much this reason. It's a lot easier to instrument in Java. The main probes that we make everyone use, they are available on all the consumer types. They're offset lag, message received, and produced on the producer side. We tend to make people that have many partitions be able to look at them, even if it's in a detailed dashboard, per partition, because we have noticed that people had trouble having visibility on like one partition being blocked, which is usually because one instance of their consumer was having issues, but they couldn't really identify that. So that has been part of it. On like the subject front, we do filter metrics that we send. So we can't do it on the Confluent side because obviously we don't control them, although we wish we could. But on the consumer side, we do filter the metrics we send to only the ones that we use in dashboards. We actually frequently audit the Datadog dashboards to make sure that we don't send extra metrics that we don't need. And one of the reasons that we have to do that, it's not only to save costs, but it's because in incidents, people would go to the metric explorer and they would try to find the right metric through there, and they would get confused about what to actually watch for. So we had to learn to essentially filter in the Datadog library configuration which metrics we are sending exactly.
All right, over on the side, please.
Hello, nice presentation, thank you. My name is Jairo Guerrero, I'm with Maersk. So I'm working on this project which eventually will become global. For now, we are working in North America and we have to implement messaging. Most of the team, we are familiar with Microsoft Message Bus. other teams in other countries are working with Kafka. So in the long run, it makes sense to go Kafka here, but we are already familiar with Message Bus, Microsoft. So I'm debating at this point whether we should invest the time to learn Kafka for the long run, or is Kafka fully compatible with Microsoft in the moment we have to integrate with the global system? Does that make sense? My question.
It does make sense. How much parallelism do you need? Like, what's the features of your system? How do the events need to be parallelized, and how do they need to be ordered?
For now, we are in the process of modernizing from monolithic to microservices. So we don't know how big this monster is going to be. I just know it can grow. There's no limit, probably. We are architecting right now. And I'm familiar with Microsoft Message Bus. I actually like it very much. But I know teams in the other side of the Atlantic use Kafka. And I would be happy to learn Kafka. The thing is, there's always a time concern, budget concern, all that. So for now, it's basic. But does it make sense to invest the time in learning all this? Is it a steep curve? Message Bus took me some time to learn, but now I could implement fast. But what are your thoughts?
So it's not a huge learning curve. The main challenge is that if you use it for use cases that it don't need Kafka, and here I'm saying like queues, if you use it for something that is strictly a single threaded queue, you are going to run into a lot more problems than if you use it for what it was made for, which is you want a number of producers and consumers that scale. So although it is a good investment, like in the long run, I would recommend starting with something that's simple for your architecture, and then you can actually migrate to Kafka when you get to the scale that actually needs it. We have done this. So I mentioned before, in the before section, we started using Kafka. For many things, we used to use SQS. For some things, like some of the infrastructure that don't require too much scale, we do use SQS still. It is a fair technology. It works. And it is pretty easy to migrate to Kafka if you know what you're doing and if you have good monitoring. And that is the main thing. You probably should invest in seeing what's happening in your messaging system, whichever you choose, before you do any migration later.
Thank you.
All right, we've got another question up here.
Hi, Josh Mills from GoPuff. I had a question about how has your experience been with the Confluent Managed Cloud, and have you had any catastrophic failures?
Well, I haven't had any catastrophic failures of the cloud. I will say that originally we had trouble in my organization where people wanted to use their support as essentially their own SRE team. That's obviously not something they do. We had a very uncomfortable vendor meeting where they explained to me that's not something they do. And I was like, I didn't write the request. We still have quarterly meetings with them for things like I mentioned earlier, the metrics. We want more granular control on metrics. We want more granular RBAC, like we are in the financial world. So we keep pushing on the features that we want, but I would say it's not different from our other vendors. And we do find like the offering generally stable once we know how to use it. And that has been that's pretty much what I mentioned in the slides, right? That has been a curve to realize how to use it, but we're pretty satisfied with what we got today.
Back over.
This is actually a pretty good follow-up from the guy who was here before, which is like the when to use Kafka, like what problems are really good fit for it. Like the queue versus stream thing I've kind of wrapped my head around, as in like SQS versus Kafka, which is more stream. But I think one of the questions is like when, like if a team is looking at Kafka, like is it sometimes right for them to just or better for them to just make a SQL database or something and like maybe use like subscribe to changes to the SQL database? How do you think about those sort of problems?
Right. So I addressed like Kafka versus queues before. Kafka versus person database is mostly about whether you need the persistency. Kafka has some persistency. The persistency is mostly for availability purposes. So it's not a system of record. It's not going to give you a guarantee that your data is going to stay there forever. And although you have some control about how much data you store in it, it's not always clear how much of that you can actually get back once you have to, for instance, replay your event log. So if you want the final state of your computation to be in a system of record then you need an actual database, and you can't use a Kafka queue to pretend to be a database. The thing that is appealing about Kafka compared to traditional SQL database for a lot of use cases is that SQL databases do tend to have one write instance where you have to write to this one instance to get your data in the transaction log. And that means that on the production side, you can scale as well as you sometimes want to. So if you have scaling needs specifically on the production side, usually Kafka, or to be fair, one of a different set of databases works a little bit better. The main use case for Kafka is really, you have things on one side, you have things on another side. You don't know how many things there can be on either side. And you want one big buffer in the cloud that's going to be kind of a conveyor belt from side one to side two. And it does work pretty well at that abstraction. Like, you will forget that it is more than a conveyor belt in the cloud. Although if you read the Kafka paper, you realize that there's a whole lot going on there.
Thank you.
One more from up front, and then we'll come back over to the side.
In a world where your company didn't have Confluent to manage your Kafka service, do you find the management overhead of Kafka and the development cycles of getting to a place where Kafka is super stable worth it?
So I have actually also done this before. I think it is worth it, but I think people understate what size team they need for it. Like, it is a service. It has to stay up. It has, although it's not a database, it does often have the same kind of uptime requirements and data integrity requirements as one. So if you have like half of an SRE to dedicate to your Kafka deployment, and you're not sure how much time you will have that person for, it's not a really great fit. And that is one thing you've actually discussed at Wealthsimple too. Like, it's the obvious, well, Confluent is doing this, but we could do this, right? We weren't services. Why do we not deploy our own Kafka? I think if you hire someone who's done it before, the initial deployment phase can be really fast. And that's like the person that had the Microsoft message bus experience. After a while, you get really good at it. You get to be the kind of person that can deploy it like that. But operating it after that is a bit too much work for one person. It's not something that you can do like without a non-call rotation for it, and without a really good system around what kind of service do you provide to the other developers.
Hi. So at my previous company, we ran a very large Kafka cluster. And one of the things that we struggled with when we were initially building it out was figuring out how to catch failures or capacity issues in the cluster before it fell over. Specifically, when you run into things like internal concurrency limits and not underlying hardware resource limits. And we kind of got to a good place eventually by brute trial and error, and we never actually found good signals to indicate that those failures were coming. I was wondering if you ever found a way to see those issues coming and what those signals were for you.
Yeah, I think one thing that can be significant in terms of like the cluster is the issue, or the cluster configuration is the issue, because it's usually that when you're deploying your own and you don't have like hardware resources problem, although disk space problem are actually pretty frequent with Kafka. But if you have like decent hardware resources, identifying configuration issues on the cluster side is usually through like elimination. You dig deep into the issues on the consumer side and you detect that this is not actually a problem. Usually it's because your consumer is not over consuming its CPU. You don't see anything weird in the consumer APM, like it's operating as normal. It hasn't actually started consuming at a very different rate. And if all these things are the case and you start having like noisy neighbors issues as well, that's also kind of a red flag. Like if you have issues on a different set of consumers than the one that's overproducing, usually that hints at there's something in your cluster configuration that's not performing correctly.
Right. I think my question was more when you're having those sorts of issues, or better yet, before you start having those sorts of issues, what metrics have you found to be good indicators of those problems so that you don't have to start failing before you notice them?
Right.
And like I said, we never found a good answer to this. So this may be, hey, there is no good answer. I'm just hoping you guys found something.
I wouldn't say it's metrics. I think the thing that's most effective at that sort of stuff is making sure that people on their Kafka clients, so both producers and consumers, they're using a standard set of configs, and that their use cases fit into what you want your deployment of Kafka to be. One way in which it's actually relevant to Wealthsimple, even though we use Confluent, is that some people sometimes come to us and they're like, oh, can we use Kafka to make X or Y real time? And you can't really get true real time by using Kafka. It's likely to work-ish if your next best thing is a SQL database, but it's not going to give you the latency you need at the end of the day. So it's a lot of like architecture upfront to redirect people away from use cases that don't work.
Thank you.
All right. Another question up here.
Hello. We are running Kafka on MSK. I have some question about how do you handle the error? Like if your server's subscribing a topic and then and there are some bug in your service. Like how do you like process some of the message, or how do you like handle that afterward?
We have a couple patterns, and to be clear, you're talking about like consumer errors on your side, right? How do you, as the zero service, deal with the errors, right? For most people, we tell them to let consumers fail if they can self-recover, because the message will then be reprocessed. So for transient errors, usually you just throw an exception. In our case, it will lead to the whole loop starting again and the messages being reprocessed when they can. Obviously, that's true async. So you are losing time. You are increasing latency by doing that. But most systems self-recover. There are cases where losing latency is actually not an option. And so, for instance, you're thinking of trading. You want to order stocks. You can't really do, I'm going to restart on this one Kafka message forever, because that's probably not going to work. So we have the letter topics that we push messages that didn't work into so that they can be retried at less busy times. We try to make sure people don't use it as a default, but that does work for identifying bad messages, because then usually when those topics get too big, the developer team will be alerted. They will look at the contents, and that has helped them identify specific messages that were leading to actions that were failing that specific system.
It's been an excellent Q&A session. I think we have time for one more question if it's a relatively short one. If anyone has, yeah, okay.
I want to go back to that one a little bit. So do you have a sink and source for that? You have another topic to store the fail message?
Yeah.
Oh, okay.
Yeah, exactly. We usually have a different topic for the dead letters.
All right. One more round of applause, please.